The European Space Agency hopes that its moon missions will be powered by batteries that use nuclear waste. European scientists are developing a breed of battery for space missions that is powered by radioactive element americium. The European Space Agency hopes that the technology will, by the end of the decade, allow it to operate spacecraft that don't rely on solar panels and can explore the moon and far-off reaches of the solar system without relying on equipment from international partners. Ministers at the European Space Agency recently approved funding for a special project to build nuclear waste-powered batteries for use in space exploration. If successful, the new tech would make it possible to conduct operations in areas where access to solar energy is degraded or absent, such as on the dark side of the moon. Researchers working with the ESA believe they can use americium, a radioactive element derived from plutonium decay, to generate sufficient heat to both warm equipment and generate electricity to power functionality. This would represent the first time americium has been used in this manner, but the innovation comes at a necessary time for the European space program. Current batteries rely on plutonium-238, an element that's challenging and expensive to produce. The US and Russia house the lion's share of the world's supply, and unfortunately, NASA barely has enough to power its own ambitions. The only option, at this point, is for the ESA to find an alternative. To that end, the ESA has earmarked 29 million euros for the development of an americium battery. According to researchers, the element is both easier and less expensive to produce. Plutonium-238 is created through a two-stage process that involves irradiating Neptunium-237 in a special reactor. It's much cheaper to develop americium, as it's derived from the plutonium that's used in the kinds of nuclear reactors used in civil power plants. Due to its relative abundance, it costs about 1/5 the price to produce an individual watt of power using americium versus plutonium-238. The current expectation is that ESA rockets will carry americium battery technology by the end of the decade. Over the next 3 years, however, the ESA's testing team will develop special prototypes for use in space-like environments here on Earth.